Hello and welcome back to Unit 11, Day 5. So we are looking at these graphs and we're having to do these key characteristics, identifying what's happening. So this number 16 we just finished in video 1 and it was that exponential. We see it did have that asymptote and those different areas, all of that information. Super. So let's look at number 17. So I see on number 17, this is a quadratic function. I know it's a quadratic function because it's going to start up here, it's going to be going down, and then it's going to come back up. It has that symmetry about it. So that is going to be our quadratic function. Excellent job. Okay, so when we take a look at number 17, just like on 16, the graph does go off, so I am going to put in arrows. If there are arrows, then we know that in the x direction, 0, -1, -2, -3, -4, those are going to negative infinities. In the y direction, +1, +2, +3, +4, +5, positive. In the y direction, we're going to positive infinity. Okay, on the other side, we see this arrow is going out, and that's +1, +2, +3, +4, +5, 6, 7. So again, positives. In the y direction, +1, +2, +3, +4, +5. So again, positives. So that's just what our arrows are doing. So think about that. So when we start talking about domain, we know that our domain, again, is our x values. And that's going to be our smallest x to our largest x. And we know our smallest x value is going to be this negative infinity. And then our largest x value is going to be that positive infinity. Super. All right, when we do our range, we're looking for our y values. Well, I'm seeing that both sides are going to positive infinity. Well, that's awesome, but that's the highest y value. What is my lowest y value? So if we're looking at our y-axis, what is the lowest y value that is on this curve? And it's right there. We're going down and back up. So that is our lowest value, and that happens at -4. So we know that at -4, it is included. It is a part of this graph. If you could draw a solid dot, then it is included. Included, you then have a bracket. Okay, this is not an asymptote. Asymptotes get parentheses. This is a bracket. And then again, our highest we just said on both sides is going to that positive infinity. Well done. Cool. All right, our x-intercept is where it's going to cross the x-axis. And we see that is going to happen two separate places. It's going to happen when x is +1, and it's going to happen when x is +5. Good job. The y-intercept, similarly, is going to be where it crosses the y-axis. And it crosses that y-axis up here when y is 5. So again, that y value is 5. All right, our maximum value. So I'm seeing that this graph is going up and up and up and up and up and up forever and ever and ever because of that positive infinity. So your maximum is none. You do not have a maximum value. Minimum, however, I do see a lowest dot. There is my lowest dot. Remember, it's called the vertex. Yeah, super. So if this is my lowest dot, what is that lowest y value? Y equals -4. So my minimum is going to be y equals -4. Well done. All right, intervals of increase and decrease. We need to figure out where is this graph going up and where is this graph going down. So starting on the left, we see that this graph is going down, 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 stop. Down is decrease. We know that we're using our x values. This is an x value of -infinity. This has an x value of +3. Again, an x value of +3. X value, not the y. So our interval of decrease then is going to be this -infinity all the way to 3. Excellent. All right, well, what is happening on the other side? So on the other side, we're going up, 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 up forever. So we are increasing on this side. Well, there's an x value, but where does it start? Again, it's an x value, so it's starting at 3. So our x value then is going to start at 3, and the highest x value, biggest x value, is going to go on forever to infinity. Good. Again, when we do intervals of increase and decrease, you have to take a look at the x values. The x values are what's going to be important when describing them. Excellent job. Okay, let's look at our end behavior. So on this end behavior, we've already labeled it on the graph. We just need to write it down. When x is positive infinity, so over here, what is my y value? Positive infinity. We already knew that. We already wrote it down. All right, on the other side, on the left, when x is negative infinity, what is my y value? Again, it's a positive infinity. With quadratic functions, your end behavior will always match. You're either both going up or you're both going down. With quadratics, it's either smiling, happy face, or a frowny face, negative. Okay? Average rate of change from 3 to 6. So again, you are welcome to do your rise over run. I see that's a pretty far distance, so I'm actually going to do the equation on this one. So I see then that my point, starting at x of 3, is down here at negative 4. So 3, negative 4. And then 6 is up here at 5. So we're going to have x1, y1, x2, y2. Now, remember back to our formula sheet. If you need to grab the formula sheet out, great, that's fine. So here's our formula sheet for Algebra 1, and we see this slope equation right there, that y2 minus y1 over x2 minus x1. So our y2 minus our y1 over x2 minus x1. At this point, we're like, okay, well, let's use our calculator. So we're going to do our table, or not table, sorry, we're going to do our fraction. 5 minus the negative 4, and 6 minus 3 to give us a final answer of 3. So we now know that our slope, our average rate of change between the interval, or on the interval 3 to 6, is a 3. Excellent. What if we wanted to do the interval 1 to 3? Awesome. Well, 1 is here, 3 is there. Those are pretty close, so I am going to do rise over run. You could still do y2 minus y1 over x2 minus x1, whatever you want. So from here, I'm going to go down 1, 2, 3, 4, and I'm going to go over 2. So down 4 over 2 simplifies to a negative 2. Notice that one of the average rates of change is positive, the other is a negative. How can that be? Because one interval is increasing and one interval is decreasing. That's fine. That's allowed. That's not a problem. Yep, there it is. Excellent job, guys. Well done. Quadratic. Woo! All right, let's take a look at number 18. Number 18, oh, that's a linear. We like linears. Linears are pretty easy. So again, I'm saying that it is going off the chart. So we're going to have our arrows. Again, this is our x value, negative 1, negative 2, negative 3, negative 4, negative infinities. It's also going up in the y direction. Up is positive. On the right-hand side, this arrow is going out, and in the x direction, those are positive values. But it's also going down in the y direction, and down in the y direction is negative values. Good job. So when we start talking about our domain and range, we then know that our domain is our x's, our smallest x to our largest x, again, negative infinity to positive infinity. When we talk about range, we have our y values. Our smallest y, negative infinity. Our highest y, positive infinity. X-intercepts is where it crosses the x-axis. That happens when x is 3. Y-intercepts when it crosses the y-axis, which happens when y is 2. Maximum and minimum. Maximum is my highest. My highest on this graph is positive infinity. Positive infinity means it's going to keep going and going and going and going. Can you get to a going and going? No. There is no maximum. All right, my minimum. My minimum, my lowest y value, again, is the negative infinity. you can't get to negative infinity because it's going to keep going and going and going and going. So again, the minimum is none. All right, let's take a look at this interval of increase, decrease. So I'm starting on the left and I see I'm going down, 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 and just keep going down forever. Again, that's an interval of decrease. Don't get tricked. What is the interval of increase? None. Interval of decrease is decreasing everywhere. Well, on the left, we started at negative infinity. On the right, we're going to keep going to positive infinity. So that's going to be negative infinity to positive infinity. In behavior, when x is a positive over here, what is my y value? A negative infinity. When x is negative infinity, what is my y value? A positive infinity. Excellent job. All right, the average rate of change from 3 to 6. So I see that my 3 to 6, 3 is here, 6 is there. I'm going to count down 1 over 3. I'm sorry, down 2 over 3. So down 2 over 3. All righty. And then my average rate of change from 0 to 6. So I'm going to do this one as the slope formula, that average rate of change formula. So I see that 0 is sitting up here at 2. 6 is sitting down here at negative 2. Again, x1, y1, x2, y2. Again, if you need your formula, it is this y2 minus y2 minus y1 over x2 minus x1. It's on the formula sheet. That's fine. Get it. Okay, in your equation then, this y2 minus your y1, x2 minus x1, grabbing our calculator, we're going to have negative 2 minus 2, 6 minus 0, and you get a negative 2/3. And we notice that with linear functions, that these average rates of change are the same. It doesn't matter where you're going to and from, it's still going to have the exact same slope. Because with linear functions, you have constant slopes. Okay, so linears, exponentials, quadratics, you got to know them all. That's wonderful. All right, guys, we are going to pause here and pick back up in the next video. Let us know if you have any questions. Thanks, guys.